For example 3.21, we're going to use the contingency table. A contingency table gives us the counts, and we have to find probabilities based off of the counts. So this table shows a random sample of 100 hikers and the areas of hiking they prefer. Now we have to check and make sure that all our columns line up. The first thing we want to do are there missing spaces here. So we want to add up and find those missing spaces. These missing spaces are easy to find because we already know that there's supposed to be 100 hikers. So we know that the total of female hikers has to be 45. So I know two of the numbers for those hikers is 18 and 16. So the remaining of hikers, I would just subtract 45 minus 18 minus 16. And when we subtract those numbers, we get 11. Now I know I can find the total here. 11 plus 14 will give us 25. I know this total has to add up to 100 because there's 100 hikers. So this corner is going to be 100. Look here, near lakes and streams. I have a total of 41 and 16 of those 41 are female. So that means the remaining number are males. So 41 minus 16 will give me 25. Let's find the males for the coastline. The males for the coastline is going to be a number where we take 55, subtract 14, and subtract 25. This gives us the remainder of 16. The last blank here is the total of these two numbers, so 18 plus 16, which is 34. And just to make sure my numbers are all correct, each one of these rows should add up to the total. So you could always add them up and check that it equals that total. Now, letter B asks us, are the events being female? Oops, let's call this letter B because letter A was filling out the table. Letter B, are the events female and preferring coastline independence? So we're looking for female and preferring coastline. And we're checking, are these independent? So for checking for independence, we first need to find the probability of, I'm going to call this F and this C. So we need to find the probability of F and C. So let's look at our table. Our table for F and C, female and coastline, is 18. So that's 18. The total number of hikers is 100. So 18 out of 100 is 0.18. The second thing we need to find is the probability of being female times the probability of the coastline. So the probability of being female, total females are 45 out of the 100 times the coastline is a total of 34 out of 100. We multiply these out and we get a decimal of 0.153. Now, in order for these two events to be independent, they need to be equal. So I have 0.18 is not equal to 0.153. So I would say no, these are not independent. Letter C asks us to find the probability that a person is male given that the person prefers hiking near lakes and streams. So for letter C, we're going to say M is the probability for male, which we know is, how many males are there? 55 out of 100. So probability of male is 55 out of 100. And the probability of L is going to be the lakes and streams. So lakes and streams is 41 out of 100. So it asks us what word tells you this is conditional, and the fact that it says male given, given is the key word. That's what tells us it's conditional. Number 2, we want to fill out the blanks for the probability statement. It has P blank line blank parenthesis equals blank. So it wants us to find this probability. So the probability of male given that he prefers lakes and streams. To find this probability, we look at male, lakes and streams, that's 25. Given the lakes, which is 41. So we're not looking at the entire total 100, we're only looking at the lakes and streams, which is 41. And then the third thing is the sample space for this problem all 100 hikers? And it's not, because it specifically tells us that it's only out of those people who like lakes and streams. All right, letter D. Find the probability that a person is female or prefers hiking on mountains and peaks. So we're going to say that F is going to be for female, and P is going to be for mountain peaks. First thing we want to do is, what is the probability of being female? So we look up at our table, there's a total of 45 females out of 100. The second thing we want to find is the probability of the peaks, mountain peaks. So let's go to our table. Probability total mountain peaks is 25 out of 100. So the probability of P is 25 out of 100. Number 3, find the probability of F and P. So both F and P. So we look at our table, female mountain peaks, that is 11. And we're looking at out of the total, so 11 out of 100. And then the fourth thing we want to find is the probability of F or P. So let's look up here. We know that F and P is going to be 45 out of 100 plus 25 out of 100. And then we have to take out the part that they have in common. And we found that to be 11 out of 100 because we don't want those repeaters. We add them up and subtract, and we get 59 out of 100. So there it is, 3 probability questions answered.